Now we're going to see the hyperboloid of two sheets. So the equation is x squared divided by a squared. You could say minus y squared divided by b squared minus c squared divided by c squared equals 1. You could say also minus x squared divided by a squared plus y squared divided by b squared minus c squared divided by c squared equals 1. Or you could say minus square x divided by square a minus square y divided by square y divided by square b plus square c divided by c squared equals 1. Alright, so it depends now in which axis you could say the hyperboloid is opening. So this, because the hyperboloid is opening to this C, you have this. You could see like when this C is like special, this difference to the other things that the other has. Here you have minus, minus, plus. Alright, so you have this hyperboloid. This is a hyperboloid which the three cross sections through the planes, the coordinate planes, produce a symmetrical surface. That is, if you cut in the xy plane, you have, well, first you have a line of symmetry. Next, if you cut in the xc plane, in this plane you have symmetry. And if you cut in the yc, you have symmetry. This this would be a hyperboloid. Looks like, well, these look the same as these that are the hyperbolas. Alright, now if you do first a cross section, if you are not here but above or below, in order to cut the surface, you have x minus x squared divided by square a minus square y divided by b squared equals, you could say, equals 0 here if you do it in the xy plane, or if you are not doing the xy plane and you just parallel to the xy plane, in order to cut the surface, you would have minus c squared divided by c squared. So here you can change the sign and you have plus this, or you could say x squared divided by square a plus y squared divided by b squared equals 0. If you, if you put c equals 0, it's 1. This is, you are cutting through the c equals 0 plane, so you are cutting through the xy plane. And these ellipses that you see when you cut below the xy plane or above or below is this ellipse that has the center, the c-axis, and vertices are in one of the hyperbola, depending on which is the largest or major semi-axis. So this would be A from here to this black hyperbola. The black hyperbola lives in the C, X, C, and X in from behind to front. So this black hyperbola lives in the XC plane. So that's A, the distance from the center to that to the vertex of the ellipse, but this ellipse is touching the hyperbolas. And this would be B, that is, in this case, I think that is the largest semi-axis, but is the distance between the center and where this hyperbola is, because it's when it is touching to the ellipse.